Okay, so hello students and welcome to the class. And in today's class we will study a particular topic which is mostly asked in the examination, like JEE Main as well as JEE Advanced. Also some mixed concepts will come from this topic, and this topic is vertical circular motion. So we are going to study about vertical circular motion. So let's discuss why we call this as vertical, why we call this as vertical circular motion, why we call this as vertical circular motion. Okay, vertical, it is a circular motion. Circular motion means if any object is moving on a circular path, the motion is called circular motion. Why vertical circular motion? Why the word vertical is used? Because the particle is moving in the vertical plane. Vertical plane means, for example, if you look carefully, the particle is not moving. There are two types of plane: vertical plane and horizontal plane. Vertical plane means like this, horizontal plane means like this. Okay, the particle is moving in vertical plane under the influence of gravity, means gravity is also involved here. So if you look carefully, let's suppose we have a particle that is moving in a vertical plane in a circular motion of radius, in a circular path of radius r. Okay, so if you look carefully, let us suppose the mass of the particle is m. Let's suppose mass of the particle is m, radius of this circular path is r, mass of the particle is m. Okay, so various concepts are involved in this total topic. So we will see, first of all we have to understand that what type of motion is this. It is a circular motion, it is a vertical circular motion. So why it is a why it is called vertical circular motion, that you understood. Second thing, I will ask you one thing, whether it is uniform circular motion or non-uniform circular motion. Uniform or non-uniform circular motion. Let's get it cleared from here. Like for example, you gave some velocity to the particle at the lowermost point u. So particle will move up. So as the particle is going up, its velocity will increase or decrease? Its velocity will decrease. Why? Because suppose, try to understand, the particle is moving in vertical circular motion. When the particle is pushed with certain velocity here, this velocity is going up, but acceleration, the gravity is acting in downward direction, so its speed will decrease because the velocity is up and the acceleration is down. So its speed will decrease. So speed will decrease again at the highermost point, at the highest point. When it crosses the highest point, it goes like this. When it goes like this, its speed again increases. Okay, so its speed is variable. What about its direction? Sir, its direction is also variable. So its velocity is variable. Overall its velocity is variable. If velocity is variable, means this is a uniform or non-uniform motion. This is a uniform or non-uniform. This is non-uniform circular motion. It comes under non-uniform circular motion. Now the next thing is 2 to 3 important thing that we have to know. Suppose, let's suppose you have tied a particle of mass m with a string. Let's suppose consider this as a string. Consider this as a string, and you are revolving that particle in a vertical circle. If you are revolving that particle in a vertical circle, you are revolving a particle in a vertical circle. Now what will happen? There will be some tension in the string. There will be some tension in the string. Yes or no? And this particle will remain in the circular path as long as there is some tension in the string. That is, the string is tight. If the string becomes loose, the tension in the string becomes zero. If the tension in the string becomes zero, the particle will no longer remain in the circular path. Second thing that is most important is, sir, you said that the particle's speed. So what is the first thing that is important? Tension. There will be tension in the string. T is the tension. So first thing, tension is important. Second thing, so as you said, sir, the velocity, speed of the particle will keep on changing. So therefore the second most important thing we should know, at any point on the circular path, we should know what is its velocity. Yes or no? Its direction as well as the speed. Yes or no? So the second thing is the velocity of the particle. At any point we should know the velocity, that is the speed as well as direction. So let's discuss about the tension. The first thing that we will discuss about tension. So in order to discuss tension, let's let's take a vertical circular motion in which a particle is being rotated with the help of a string. With the help of a string, the particle is being rotated. So in the string there will be tension. So let's suppose at the lowermost point we have given how much speed to the particle. U speed has been given to the particle. The particle will start rotating in the anti-clockwise sense. Yes or no? In the anti-clockwise sense, the particle will start rotating. Now the second thing is that at any point, let's suppose at any arbitrary point P, I want to calculate the tension in the string. So what I will assume, what I will do, look carefully. Let's draw the free body diagram of the particle at this point. What are the forces that are acting on this particle? One is mg in the downward direction. Let this angle is theta. What is angle theta? Theta is the angle made by the string with the vertical line. So this mg will be acting in downward direction. Mg will have two components. One is mg sin theta, y sir mg sin theta, and one is mg cos theta, y mg cos theta. Because if I ask you, this angle is theta, this angle is theta, then this angle with these two lines are parallel, therefore this angle will also be theta. So this is mg sin theta, this is mg cos theta. If you look carefully, there will be a tension in the string. So at any point P, at any arbitrary point P, at point P we want to calculate the tension. So if you look carefully, tension T, you look carefully, let the velocity at point P is Vp. Let the velocity at point P is Vp. Wait 1 second. Let the velocity at point P is Vp. This is U. Okay. And now we want to calculate tension. If I ask you, what is the net force on the particle towards the center? What is the net force on the particle towards the center? That is tension minus mg cos theta is the net force towards the center. Net force towards the center is called centripetal force. If net force towards the center is called centripetal force, so do you remember the formula centripetal force? That is mv square by r. Okay, so here it is equals to, what is the radius? Radius is r. Radius of this circular path is r. So do you remember mv square, m into v square? What is the velocity at this point? Vp square divided by r. If you look carefully, P is a general point. So tension is equals to what? Sir, mg cos theta plus m into Vp square by r. R is the radius of the circular path, or you can also say that in some of the books you will see that this r is written as L. L means what? The length of the string. This is the length of the string. Now, but our work has not been completed till now. Tension, you look carefully at the tension. Sir, tension is mg cos theta plus mvp square by r. If I ask you, tension is variable or constant? You will say that, sir, tension is variable. Sir, why tension is variable? Because it depends on theta. As the particle is moving, the angle theta will also be changing. Yes or no? When the particle is at this point, angle will be 90. When the particle reaches at the highest point, the angle will be 180, like that. So theta is changing, tension is changing. So tension depends on theta. It means tension is also variable. Tension is also variable. Another thing, it depends on the velocity. It depends on the velocity of the particle at that particular instant. So let's generalize more. I want to remove this Vp square. How we can generalize more? If you look carefully, I want to remove this Vp square. So look carefully. Let's draw another diagram. What I consider here, we have a particle. Center of the circular path is this. We have a particle which is projected with a velocity u, and it reaches after some time at point P with velocity, and the velocity at this point becomes Vp. Initial velocity is u. So if you look carefully, the radius is how much? Radius is r. Okay. And this angle is how much? Theta. So if you look carefully, I am going to do one thing. I am going to, this is the lowermost point, let's call it point A. I am going to do one thing. Let's apply energy conservation between point A and P. See, in case of vertical circular motion, two concepts are generally maximum used. What are those two concepts? First is Newton's second law, which we have just used. You will say that how sir Newton's second law is used? You look carefully. The net force is equals to mass into centripetal acceleration. Second thing that we will be using very heavily, that is energy conservation. As the particle moves from A to point P, how the energy is conserved. Why we can apply energy conservation? You have, whenever you are applying mechanical energy conservation, to be very precise, mechanical energy conservation, that is kinetic energy plus potential energy, that is equals to total mechanical energy. When we apply mechanical energy conservation, we have to be careful that we have to check whether there is any non-conservative force are involved or not. If they are involved, we cannot apply mechanical energy conservation. So you have to be clear on that. Look carefully. So I am going to apply total mechanical energy conservation, mechanical energy conservation between A and P. So mechanical energy, total mechanical energy at A is equals to total mechanical energy at P. Let's try to write down. Whenever we apply energy conservation, you people should also understand, students, you should also understand that we have to take a reference level. Let's take this point as a reference level. Reference level means what? Reference level means what? It is the point where we have assumed, it is the level where we have assumed the potential energy to be zero. It is assumed until and unless stated otherwise. Okay. So if potential energy at A is zero, so potential energy is zero. What is the kinetic energy at A? Half into m into u square. Okay. This is equal to what is mechanical energy at P. So we have to understand what is the potential energy at P. So we have to understand. Let's suppose this height is h. This height is h. So what is the potential energy at P? M into G into h. And what is the kinetic energy at P? Plus half into m into velocity at P ka whole square. So m se m get cancelled. What is remaining here? U square by 2 is equals to gh plus Vp square by 2. Okay. Now further we want to calculate Vp square. We want to replace Vp square. Our motive is to replace Vp square. I will also let you know very basic thing that why we replaced Vp square. So Vp square we can write next in the next page. Vp square by 2 is equals to what? Sir, Vp square by 2 is equals to gh plus u square by 2. Let's multiply by 2. We will get Vp square is equals to twice of gh plus u square. Okay. If you look carefully, Vp square is equals to what? U square plus, actually wait one second, just a second. Here gh plus Vp square by 2 is equals to u square by 2. So Vp square by 2 can be written as, wait one second, Vp square by 2 can be written as, here it should be u square by 2 minus gh, u square by 2 minus gh. So if you look carefully, it will be Vp square is equals to what? Vp square is equals to u square minus twice of gh. One more thing, sorry. We have to understand what is h. We have to replace h also, because we don't know h. What do we know? We know r, we know theta. So we have to write h in terms of r and theta. Let's look carefully. This is h. What is this total length? This total length AC. Total length AC is equals to r. Many students fail to understand this. Total length is AC, that is equals to r. And let's suppose this point is PAB. This point is B. If you look carefully, what is CB? If you look carefully, what is CB in this triangle? CB is equals to what? R cos theta. CB is equals to R cos theta. R cos theta. So if I ask you what is the value of H, so H is equals to what? H is equals to AC minus BC. AC minus BC, that is equals to what? R minus R cos theta. Hope you have understood this. H is equals to what? R minus R cos theta. So if you look carefully, I will replace this thing. I will replace this thing H here. So Vp square is equals to U square minus 2 into G into R. R you can take common. R minus R cos theta means R you can take common, 1 minus cos theta. If you look carefully, what is the value of Vp square? Vp square is equals to U square minus 2GR, 1 minus cos theta. One more thing. Many students will wonder, sir, why there is a need? If you look carefully, we have written the value of tension at any point, mg cos theta plus m into Vp square by R. But do you know theta? Yes. Do you know mg? Yes, we know. Do you know Vp? Sorry, do you know Vp? No, we don't know the velocity of the particle at any intermediate point. So what we have to do? We have to convert into something. We have to replace it by something which we already know. What do we know? We know the velocity at the lowermost point. This is the velocity given by us, okay, at the lowermost point. So if you go by this, so if you look carefully, now we have successfully done that. Vp square is equals to U square minus 2GR into 1 minus cos theta. Do you know U square? Yes, this is the velocity given by us at the lowest point. And do we know GR? Yes, we know theta. Everything is known to us. Now you got Vp square. Means this formula is important. First formula, we got this. This formula is important. This will help you to calculate the velocity of the particle at any point. So one more thing. We should not be heavily dependent on the formulas, but we should be very careful about the concepts. How this formula came? How this formula came? This formula came by just applying energy conservation. So if I ask you, if any students comes and ask you what are the two key concepts that will be used in the vertical circular motion, that are energy conservation and net force is equals to mass into acceleration, that is Newton's second law, that is net force towards center, that is centripetal force is equals to mass into centripetal acceleration. These two key concepts will be used. So while solving the question, these things are done so that you can analyze the whole motion, what is happening, okay. And formulas, if you remember this formula, that is very well and good, but you should remember this formula. 70% of the time it will cut short your time which you are taking in case of questions, okay. But since we have a lot of concepts and a lot of formulas, we cannot we cannot cram all these formulas, but basic formulas must be remembered and concepts must be remembered.